Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. This video is the third part in complex numbers chapter, and here we are going to see how to find the solutions of different polynomial equations such as quadratic, cubic, quartic, etc. You will also be learning how to sketch these polynomials when they have real or complex roots. So let's get into the video now. Are you ready?
Now, you need to have a knowledge about solving quadratic, cubic, and quartic before you watch this video. So, if you have not learned about how to solve quadratic, cubic, or even quartic, it is suggested that you learn that and then come to this video. Okay, the first thing is solving quadratic. So let me give you two quadratic equations and then you can solve these two. Pause the video, try to solve them, and then come back to see if your answer is correct. Here are the answers for this. Hope you were able to get these answers when you solved them. The answers here are minus 6 plus or minus square root of negative 4 over 2 for the first one, and for the second one minus 1 plus or minus square root of minus 3 over 2, and which is here. Now let's start simplifying this, and you can see very well that this part, the discriminant part, is negative, therefore we are going to have complex numbers as its answer. So how will you simplify square root of negative 4? So this can be written as square root of 4 times square root of minus 1, and square root of 4 is 2 and square root of minus 1 is I. Therefore square root of minus 4 is actually 2I. So this can be written as minus 6 plus or minus 2I over 2. Or in short, if you simplify this further, this is minus 3 plus or minus I. Actually, this is minus 3 plus I is one answer and minus 3 minus I is another one. And you can see that they are conjugate of each other. So A plus BI and A minus BI are called conjugates. If you have watched my previous video, you know what conjugate is. So conjugate is changing the imaginary part. Plus B becomes minus B, but the A, the real part, remains as it is. How do you simplify this? Minus 1 plus or minus square root of minus 3. I can write square root of minus 3 as square root of 3 times square root of minus 1, which is I. Therefore, square root of minus 3 is square root of 3I. So this becomes minus 1 plus root 3I over 2, or minus 1 minus root 3I over 2. And you can split this and write it into proper complex form, which is minus half plus root 3 over 2I, which is A plus IB, or minus half minus root 3 over 2I. So you can see again that this and this are conjugate of each other by changing its imaginary parts. So let's move further and solve a little more of quadratic equations. Now try to solve them by pausing the video and check your answers here. This is the answer. And in this case, you have minus 6 plus or minus square root of minus 24 over 6. Minus 24 can be simplified further as square root of maybe minus 6 times 4 divided by 6. Or you can even use 8 times 3, but 8 is, they are not going to help us to remove from the bracket, from the square root. Therefore, this is minus 6 plus or minus 2 root minus 6 over 6, and this can be written using complex number, imaginary number, square root of 6 plus or minus 2 square root of 6 I over 6. You can either simplify this as minus 1 plus or minus 2 over square root of 6I if you are comfortable, or you can leave the answer here, which means that you are still getting conjugate pairs as its answer. So when do you actually get conjugate pairs? You get conjugate pairs when the coefficients of the equation are real numbers. When you have imaginary coefficients, then this will not be a case. You cannot get a plus bi and a minus bi as the roots. They may be completely different. But you get conjugate roots only if all the coefficients are real. If I have something like 3i x square plus 4x minus 4i equal to 0, something like this, and you can see that the coefficients have I in them, which are complex numbers. Therefore, in this case, the coefficients are complex, and it doesn't give you roots with conjugate pairs. So roots with conjugate pairs will occur only when you have equations with real coefficients. And in this case, you cannot simplify root of 51, therefore you can just write this as square root of 51I over 2 plus or minus, and therefore they are conjugate to each other, and you can still see that the coefficients are real numbers. It could be positive, negative, decimal, anything but real numbers, not complex. Let's move on to cubic. Z cube minus z square minus z equal to 15, and in order to solve cubic you need to find the first real root using trial and error. And there is one more, cubic z cube plus 6z equal to 20, and try to solve them before you can see the answer on the video here. And these are the answers. So z equal to 3 is the first real root, and you should have noticed that the equation starts now using z as its variable, not x, because when we are dealing with complex roots, usually the equations are in z, not in x anymore. So z equal to 3 is a root, z minus 3 is a factor, so divide the equation by z minus 3, and then you will get a quadratic, and solving the quadratic as you would, and in this case you cannot factorize them, therefore you solve by using the quadratic formula, and you get minus 2 plus or minus square root of minus 16 over 2. In simpler form it will be 4I over 2, and you can still simplify this minus 1 plus or minus 2I, and still you can see they are conjugate pairs because the coefficients are real. Coming to the next question, I hope you would have solved this using the first trial and error method to get the first real root, which is 2, and in this case the roots here, complex roots here, can be written as minus 1 plus or minus 3I if you simplify this further. And the roots for this equation, the cubic equations, are 3, minus 1 plus 2I, and minus 1 minus 2I. You should not forget the first 3, which was found by using the trial and error method. And in this case the 3 roots are 2, which is a real root, and minus 1 plus 3I, and minus 1 minus 3I, which are 2 complex conjugate roots. So how does this affect the graphs? What about quadratic? Quadratic has 2 roots, z minus a, z minus b, and again you can notice that I've started using z because there is a possibility of having complex roots. So when both a and b are real roots, then the quadratic would look like this, either up or down. So I'm just using one part. So basically speaking, you'll have 2 roots on the x-axis. The graph cuts the x-axis at 2 points when a and b are real roots. And if a is equal to b and still they are real roots, then you know that it touches the x-axis because you have equal roots. But when a and b are complex roots, you know that complex roots occur when the discriminant is less than 0, and when we were doing quadratics we said there are no solutions, but now we have produced the solution. This solution is called complex solution, but we cannot represent them on a real number, a real coordinate axis, but so you will have the quadratic curve to be like this, not cutting any of the x values on the x-axis. Therefore, it's either above or below the x-axis, and it doesn't cross or touch the x-axis when the roots are complex. So this can be applied to cubic as well. So cubic, you have 3 roots. In these 3 roots, one root has to be real. Remember that this was a real root we found by using trial and error method, and the other 2 roots could either be complex or both are real. So if one is complex, the other one is complex. So if one is complex, then both the roots should be complex. Okay, so there are only 2 possibilities where all of them are real, or one real and 2 complex. You can't have two real and one complex, because one complex number cannot occur separately. It has to be going on with its conjugate pair. So it's always 2 at a time when the coefficients are real. Therefore, if you have all 3 real numbers, you know that a cubic looks like this, where it cuts the x-axis at 3 different points. But when you have one real root, then the cubic crosses the x-axis at one point, but later it doesn't cross, but it goes like this. So when b and c are complex numbers, then the curve actually crosses the x-axis only once. The same thing applies for quartic, but quartic is more interesting because you have four roots, and a general quartic will look like this or will look like this. Okay, a W curve. So you can have possibilities of here is A, B, C, D all real, or if you have you can see this as two quadratic, right? So the same thing applies. So you can have two real from the first quadratic and two complex from the second quadratic, or you can have all of them complex. Okay, as I said, you cannot have one real and three complex. I cannot have like A real and B, C, D complex because I need to have complex roots in pairs. So if this was the case, A, B, C, D real, then the curve would look like this, where it crosses the x-axis four times. And it could be the other way around as well, depending upon the coefficient of z power 4. Now, two real and two complex. Let's move on to two real and two complex. So in this case, it cuts the x-axis twice, like this. And then furthermore, there are no crossing the x-axis, so the equation, quartic equation would look, the function would look like this. It doesn't cross the x-axis anymore. And obviously when all four are complex number, it doesn't cross the x-axis at all, so it should either look like this or look like this, above or below the x-axis. Hope this is clear here. How to get the polynomials using roots? That is, you are given the roots. How do you get the quadratic, cubic, or quartic? For quadratic, both real roots, you need to have both the roots given. For example, you can find the quadratic equation whose roots are 2 and 3. In this case, you can easily find the quadratic like x minus 2 times x plus 3. That's easier. But if you have both are complex roots, that's the other option that quadratic can have, then you need to use this property. Complex roots of a polynomial with real roots, always they occur in conjugate pairs. So in this case, it's enough if you are given one complex root and you can find the other one like as its conjugate. Therefore, the two roots are 2 plus 3i and 2 minus 3i. So I will start using z because we have complex roots. So the first a linear pair would be 2 plus 3i, right? And then the other factor would be z times 2 minus 3i. And you need to multiply these two factors. It's easy to multiply. Like you can expand this z minus 2 minus 3i, the first one. Open the bracket for the complex number, z minus 2 plus 3i. Once you open the bracket, then you can identify that it's of the form a minus b and a plus b, which gives you a, this is a square minus b square. And you should remember that always I square is minus 1. Therefore, this is z minus 2 the whole square minus 3 times minus 1, which is 3 square, which is 9 times minus 1. Therefore, it's plus 9. And if you simplify this further, that's z square minus 4z plus 4 plus 9. And this becomes z square minus 4z plus 13. So this is the quadratic equation with these two roots, complex roots. You can try them out using quadratic formula and you'll be coming to this solution. Okay, hope you understood that. Especially this part is more complicated. You cannot use a minus b, a plus b in this area. You need to simplify this to this level and then you can use a minus b, a plus b formula here. Next, what if it's a cubic? You are supposed to find a cubic. So what are the characteristics of cubic? Cubic can have one real root, two complex roots, or all three real roots. Okay. So if all three are real roots, you need to have all these three real roots in order to find them like this. 1, minus 3, and minus 2 and 3. So your cubic would look like this. Right? And you can simplify this. The other case is if cubic has one real, two complex, it's enough to know the real root and one complex root like this. So you have the real root 4, which gives me z minus 4. And then This will give me the other root is 3 plus 2i. So I can get them 3 minus z minus 3 minus 2i and z minus 3 plus 2i. And as I explained before for quadratic, you can simplify these two into quadratic and then multiply that quadratic with z minus 4 to get the cubic. Moving on to quartic. In quartic, you can have different options. All four real roots, two real and two complex, all four complex. If all four are real roots, of course, you need to be given all the four real roots so that you can make the equation like this with linear factors. And this is easy, you would have done this before. It has two real roots and two complex roots. What do we need? You need both the real roots, and it's enough if you have one complex root so that you can get the other complex root. Now you have 4, 1, 2, 3, 4, and you can use this technique as z minus 3 times z minus z plus 5 in this case, and these two can be simplified to a quadratic, and the next part can be simplified together as another quadratic. Then you need to multiply both the quadratics together to get the quartic. Okay, when four of them are complex roots, again it's enough if you know two of them, like this will give you the second 3 plus 4i, the conjugate of this, and the conjugate of this. Now you have four roots and you can use them to simplify, like put the conjugate roots together so that you can simplify as I explained to you on quadratic. And then so I'm writing the conjugate factors together, the factors with conjugate roots together. So these two together will be forming a minus ba plus b form, and then these two together will be forming a minus ba plus b form, and then you'll have two quadratic, then you can multiply the quadratic to make the quartic. Hope you enjoyed this video. Again, as I said, practice more makes you more perfect. So practice more and more and more problems, then you'll understand what is behind the scenes of these wonderful concept. Bye bye. See you in the next video.
Meanwhile, please subscribe to this channel and like and share the videos if you like them. Thank you.